Hi there, welcome to Grade 10 Mathematics. This is the continuation of Disguise Quadratic Equation under the umbrella of Maths by U by Attaur Rahman. In today's lecture, we will discuss two more types of Disguise Quadratic Equation. That is, the first one, an equation of the form a time p of x plus b upon p of x is equal to some constant, while second equation is also a disguised quadratic equation, that is an equation of the form ax4 plus bx cubed plus cx square plus bx plus a is equal to 0. We will try to learn the procedure how to solve these two types of disguised quadratic equation. Okay, so what we are waiting for? Let us start our first type of disguised quadratic equation. In this type of equation, we will face two terms which will be the reciprocal of each other. In the first term, we will have p of x, while in the second, we have 1 upon p of x. So, let us solve an example on this. Suppose we have given an equation of the form that x minus 1 upon x plus 3 plus x plus 3 upon x minus 1 is equal to some constant, that is 13 by 6. This is our first equation. Here you see that the term that is x minus 1 upon x plus 3 and x plus 3 upon x minus 1 are the reciprocal of each other. So we will let one of them as y, that is x minus 1 upon x plus 3 is equal to y, and mark this as our second equation. So definitely x plus 3 upon x minus 1 will be 1 upon y, and this will be our third equation. Now it's the time to replace these two equations 2 and 3 in equation 1. Why? To get equation 1 in the standard form of quadratic equation. That is, we will have y plus 1 upon y is equal to 13. But still, this equation is not in the standard form of quadratic equation. That is, it's still a disguised quadratic equation. We will clear the denominator to get the given equation in the standard form. That is, we will multiply throughout by 6y. So the first term will be 6y square. The second will be the constant 6, and the right hand side will become 13 times y. Now putting this equation in the standard form of quadratic equation, we will get 6y square minus 13y plus 6 is equal to 0. Now apply any one of the method you have learned previously, that is factorization, completing square method, or using quadratic formula. So here we apply the factorization method to solve this equation. And there you know what is factorization, how to factorize this. We will look for two terms to split 13 such that their sum will equal to 13 and their product will equal to the product of the coefficient of y square and the constant term, that is 6 multiplied by 6, that is 36. Fortunately, we have found those terms, that is minus 9 and minus 4 works for us. So we will factorize the given equation like this, that 6 times y square minus 9y minus 4y plus 6 is equal to 0. So clearly in the first two terms we have a common factor, that is 3y. So taken out this as a common factor, we will get inside the parenthesis 2y minus 3, while in the second we have 2 as a common factor. So we will taken out this as a common factor, and inside we left with 2y minus 3. So dear, you see this is the factorization of the given equation. Now we know a well-known method, that is the zero product property. That is, if a cross b is equal to 0, then either a is equal to 0 or b is equal to 0 or both is equal to 0. So applying this property to the above, we have 2y minus 3 is equal to 0 or 3y minus 2 is equal to 0. Now these are linear equations. We know the methods how to solve them. That is, y will equal to 3 upon 2 or y is equal to 2 upon 3. But keep in mind, these are not our solution. Our solution must be in the original variable. So we must switch them to the equation where x was connected to y. Certainly that equation is equation number 2. So we will replace y is equal to 3 upon 2 in equation 2 to get the value of x. That is, x minus 1 upon x plus 3 will equal to 3 upon 2. Now this equation can be solved by cross multiplying. We get an equation like this, that is 2 into x minus 2 is equal to 3 into x plus 9. Now solving this, we will get the value of x as x is equal to minus 11. Now switching y is equal to 2 upon 3 in equation number 2 to get the other value of x, that is x minus 1 upon x plus 3 will equal to 2 upon 3. Now again, by cross multiplying, we will get the value of x, that is 3 times x minus 3 is equal to 2 times x plus 6, and this clearly gives the value of x as x is equal to what? Just tell me, x is equal to, yes, of course, that is 9. And finally, we have obtained all the roots of the given equation in x. So now the final step is to put these roots in a solution set known as the solution set of the given equation. Now dear, we are moving toward our second disguise quadratic equation in this lecture, that is a reciprocal equation. What is a reciprocal equation? A reciprocal equation is an equation in which coefficients from the beginning and the end are the same. It will be an equation in which the coefficient of the first term and the last term, the second term and the second last term, etc. will be the same. Let us introduce the standard form of the reciprocal equation. That is, it is an equation of the form that ax4 plus bx cube plus cx square plus bx plus a is equal to 0. Here we see that the coefficient of the first term and the last term, the second term and the second last term are the same, but we have an unpaired term, that is cx square. Let us take an example, that is 2x4 minus 9x cube plus 14x square minus 9x plus 2 is equal to 0. Here again, the coefficient of the first and the last term, the second and the second last term are the same, but we have an unpaired term, that is 14x square. Since given that 2x4 minus 9x cube plus 14x square minus 9x plus 2 is equal to 0. Suppose this is our first equation. Now, what to do next? We will rearrange the terms. That is, by rearranging the terms that have the same coefficients. That is, first we will write 2x4 along with 2, then minus 9x cube minus 9x, and then 14x square. Now we will take out the coefficient from the first two terms, and then we will left with an unpaired term, that is 14x square. Okay. The next step is to divide the whole equation by the variable containing in the unpaired term. That is, we will divide the whole equation by x square, and we will get an equation of the form, that is 2 into x square plus 1 upon x square. Why? Because if x4 is divided by x square, it will reduce to x square, and then we will divide 1 by x square, so it will left as 1 upon x square. the second term will take the shape as minus 9 into x plus 1 upon x, and the last term, that is the unpaired term, will get the shape as just 14 is equal to 0. Now this is our second equation. Now in this equation we will replace the terms, that is x plus 1 upon x and x square plus 1 upon x square, by some other variable to get the given equation 2 in the standard form of quadratic equation. So we let x plus 1 upon x is equal to y. And how to find the value of x square plus 1 upon x square then? How? Tell me just. Okay? Oh, yes, of course, we will square equation 2 to get the value of x square plus 1 upon x square. Now we all are familiar with the basic identity that if a plus b whole square is there, then how to expand the formula, that is a plus b whole square is equal to a square plus b square plus twice first into second. So here we are using such formula, that is x plus 1 upon x whole square is equal to what? X square plus 1 upon x square plus twice into first into second, and in the right we have y square. So in the left we have, that is x square plus 1 upon x square plus 2, because x got cancelled with x, and we left with x square plus 1 upon x square is equal to y square minus 2, and mark this as our equation 4. Now what to do next? We will replace equation 3 and equation 4 in equation number 2 to get the given equation in the standard form. Now let's plug in equation 3 and equation 4 in equation 2 to get the given equation in the standard form. That is, we will replace x square plus 1 upon x square by y square minus 2 and x plus 1 upon x by y. After some algebraic manipulation, the above equation will take the shape of the standard form of quadratic equation, that is 2y square minus 9y plus 10 is equal to 0. Now dear, you see that this is a standard form of quadratic equation. We can solve this by any of the method we have learned previously. Here we are trying to apply factorization. We will split 9 into 2 terms, that is minus 5 and minus 4, such that the sum of minus 5 and minus 4 get back what? Minus 9, and the product of minus 5 and minus 4 gives what? The product of 2 and 10, that is 20. Yes, of course, it gives what? Minus 5 multiplied by minus 4 gives 20. So fortunately we have found those terms, that is minus 5 and minus 4. So factorizing this equation, it will give 2y minus 5 and y minus 2 is equal to 0. Now, so this equation can be solved with the help of, here we will use the zero product property as we have used in the previous one. That is, we will use 2y minus 5 is equal to 0 or y minus 2 is equal to 0. And these are clearly the linear equations whose solutions are 5 upon 2 and 2. Now, we will switch these values of y into the equation where x is connected to y. Okay, so let us do this. First we will plug the value of y is equal to 5 upon 2 in equation 2. Okay, so this will take the shape that is x plus 1 upon x is equal to 5 upon 2. And now how to solve this equation? You know, we will clear the denominator because it is still a disguise quadratic equation. We will clear the denominator by multiplying throughout by 2 times x, and this equation will take the shape as 2x square minus 5x plus 2 is equal to 0. That is the standard form of a quadratic equation. Now solving this equation, we will get the value of x. Here again we are making use of factorization. to solve this quadratic equation. That is, we will get the factors of the given equation like x minus 2 into 2x minus 1 is equal to 0. And again, we will use the zero product property to get the value of x, that is x is equal to 2 or x is equal to 1 upon 2. So these are the first two roots of the given disguise quadratic equation. Now we are using y is equal to 2 in equation 2 to get the other values of x. Okay, that is x plus 1 upon x is equal to 2. Again, squaring this and reducing to the standard form of the quadratic equation. Here we see that this is a complete square of x minus 1. Now taking square root of both sides, it will take the shape as x minus 1 whole square under the radical sign is equal to plus minus 0. But we know that 0 does not contain any sign. So we will get x minus 1 is equal to 0, which is linear equation, and hence its solution is x is equal to 1. That is, the root of the given equation is now x is equal to 1. So we have obtained three different roots of the given equation, that is 1 upon 2 and 1 and 1 over 2, which is the solution set of the given equation. Hope you understand both the methods. Now it's a time to subscribe the channel, like it, and do not forget to press the bell icon. Positive comments will be addressed in the comment box. Thanks for watching.